For more videos, visit forthesakeofeducation.com. Alright guys, now we're going to do these two problems together that they want you to replace the distributed loading into a point measure from point A, a vertical point measure from point A, and a horizontal point measure from point C. So the first thing you need to do is you need to find the equivalent forces. So this rectangular force has an equivalent force of F1 acting right in the middle of the rectangle, and same thing goes for F2 acting right in the middle of the second rectangle. So F1 is equal to the area of the rectangle, which is 3 kilonewtons per meter, times the length of the rectangle, which is 3, which is equal to 9 kilonewton meters. F2 has a magnitude of the area of the rectangle, which is 2 kilonewton meters, times the length of the rectangle, which is 4 meters, which will make it L kilonewtons. So the first thing you need to do is find the moments about A. We're going to do the first part, and then what we got to do is we got to find the moment that these two distributed loads create about A. Assuming counterclockwise is positive, the moments about A are F1 times this distance right here, which is where it's applied, which is half of this rectangle. The rectangle is 3 meters, therefore half is 1.5. And F2 also creates a clockwise moment, so it's positive, times, and it's turning this arm right here. And this arm has a length of 2 meters because it's half of 4, so it's 2. So this comes out to be 29.5 kilonewton meters. Now the resultant force, Fr, is equal to 8 in the I plus 9 in the J, because we have a vertical and a horizontal force. So assuming the positive X will be this way and positive Y will be this way. So this is X, this is Y. That's why they're both positive. The magnitude of this resultant force is found by doing the square root of the X component square plus the Y component square, and it comes out to be 12.04. And the angle theta that it forms, it's 8 in the I, 9 in the J. So this angle theta is given by the tangent inverse of 8 over 9, which comes out to be 48.4 degrees. So they want you to find where would this horizontal force be applied from A to create the same moment. Now remember, the resultant force is at an angle, so basically the force is applied at an angle like that. And then they want you to find the distance from A where this force will be applied. So let's do the first one. The first problem will be the moment created is 29.5. So the moment is equal to the force times the distance. The moment is 29.5. Now what would the force be? The force applied here in this manner, you know that this force has two components, a horizontal component and a vertical component. However, the horizontal component is creating absolutely no moment because it aims directly at A. So all we have to use is the vertical component. And the vertical component is 9 because it's the Y component times the distance. So we use the Y component right here. So D comes out to be 3.28 meters. And that is for the first one. So this is the resultant force, the equivalent magnitude, and it's applied 3.28 meters because it's applied diagonally. Now the same thing goes for the second problem. The second problem, the force is applied diagonally somewhere over here. Now this force has a vertical component and a horizontal component and a vertical component. Now the vertical component is doing no moment about C. So the first thing we need to find now is the moment created about C. Now let's assume counterclockwise is positive. So the moment about C is equal to 1.5 F1 because F1 is turning this lever arm, plus 2 F2 because F2 is turning this lever arm and it's turning both counterclockwise, and it is equal to, again, 29.5 kilonewton meters. Now notice, you might be saying, oh, it's the same magnitude as the other one, but there's a slight difference. This one is clockwise, this one is counterclockwise. So the moment is equal to the force times d, the distance. The moment is 29.5. Now what's the force? Now it's the other way. We used the vertical component before because the vertical component was the only component of the force creating a moment. Now we have to use the horizontal component because the vertical component aims straight at C. So the horizontal component is 8 times d, and d becomes 3.69 meters. So what does this all mean? This means that you will have the force will be applied. Actually, let me try to make the right distance. So this force is at 328 and this force at 369. So this force will be applied somewhere over here, 328, and this force will be applied at 369, will be somewhere over here. Final answer for the first one and second one.
Please comment below if you want me to do any problems and I'll be happy to help. Thank you.